Imagine the ground beneath you suddenly shaking, or a fiery eruption lighting up the sky, or a massive wave swallowing entire cities. These are not scenes from a movie, they're the devastating forces of nature. For millennia, these events have terrified and mystified humankind, leaving destruction in their wake. But what causes these disasters? What are the forces at play that unleash such raw power upon our world? Let's embark on a journey into the heart of our planet and uncover the science behind earthquakes, volcanoes, and tsunamis. Our planet might seem solid, immovable, the very definition of terra firma, but beneath the surface, Earth is a dynamic, restless being, constantly in motion. The Earth's crust, that seemingly solid ground beneath our feet, is fractured into gigantic pieces, like a jigsaw puzzle on a cosmic scale. We call these pieces tectonic plates, and they're in constant, albeit incredibly slow, motion, drifting over the mantle. Picture them drifting atop the Earth's mantle, a layer of hot, viscous rock that flows like a slow-moving river. These plates, in their relentless dance, push against each other, grind past one another, and sometimes even pull apart, creating immense geological tension. The boundaries where these plates meet are called faults, and they are the epicenters of Earth's seismic activity where the most dramatic events occur. Imagine two tectonic plates meeting, their edges jagged and rough, locked in a geological standoff, unable to move past each other. The pressure builds for years, decades, even centuries, as these colossal forces push against each other, storing energy. The energy stored is immense, like a coiled spring stretched to its breaking point, ready to release its force. And then the inevitable happens. The fault ruptures, releasing the built-up energy in a sudden, violent motion. The pent-up energy explodes outward, rippling through the Earth's crust as seismic waves shaking the ground. These waves travel at incredible speeds, reaching every corner of the globe, spreading the impact far and wide. We feel them as earthquakes, the ground shaking beneath our feet, a stark reminder of the immense forces at play beneath the surface. The intensity of these tremors, the violence of the Earth's shudder, is measured on a scale we call the Richter scale, a tool for understanding the power of these events. Each increment on this scale represents a tenfold increase in the amplitude of the seismic waves, a logarithmic measure of their power. A magnitude 2 earthquake might be a gentle tremor, barely noticeable, a mere whisper of the Earth's movement. But a magnitude 7 earthquake, that's a force of nature capable of toppling buildings, shattering infrastructure, and forever altering the landscape, a true testament to the Earth's power. One of the most powerful earthquakes in recent memory, the 2011 Tohoku earthquake off the coast of Japan, registered a staggering 9.0 on the Richter scale, a monumental event. The seismic waves radiated outwards with unimaginable force, unleashing a devastating tsunami that wreaked havoc across the Pacific, a chain reaction of destruction. The event was a stark reminder of the immense power of nature, the raw energy that lies dormant beneath the surface, waiting to be unleashed in moments of sheer force. But earthquakes are not merely destructive forces, they also play a crucial role in shaping our planet. They are also architects of our planet, shaping the very land we inhabit, creating the diverse landscapes we see today. Over millions of years, these seismic events have thrust up mountain ranges, carved out valleys, and created the continents we call home. A testament to their creative power. They are a testament to the dynamic nature of our planet, a constant reminder that Earth is not a static stage, but a living, breathing entity, ever-changing and evolving. Imagine a mountain, not just any mountain, but one that breathes fire, spewing molten rock and ash into the sky. This is the awe-inspiring power of a volcano. Volcanoes, these fiery giants, are perhaps the most visually spectacular manifestation of our planet's inner turmoil. They are both creators and destroyers, shaping the landscape in dramatic ways. They are windows into the Earth's fiery heart, offering a glimpse into the immense forces that shaped our world. Through their eruptions, we witness the raw power of nature. Deep beneath the Earth's crust lies the mantle, a region of intense heat and pressure. This is where the story of a volcano begins. Here, molten rock known as magma churns and bubbles, seeking a path to escape the inferno. The journey of magma is a relentless quest for release. Volcanoes are born when this molten rock finds its way to the surface, erupting through weaknesses in the Earth's crust. These eruptions can be both sudden and violent. Picture a magma chamber, a vast reservoir of molten rock miles beneath the surface. This chamber is the heart of a volcano. Pressure builds within this chamber, fueled by the constant influx of magma from the mantle. The pressure continues to mount, creating a ticking time bomb. The pressure intensifies, pushing against the surrounding rock, seeking an outlet, a release valve for the immense energy building within. This is the prelude to an eruption. And then, with a roar that echoes across the land, the volcano erupts. The ground trembles and the sky darkens with ash. Molten rock, now called lava, spews forth from the vent, cascading down the slopes in fiery rivers. These rivers of lava reshape the landscape. Ash and gas are ejected skyward, forming a towering plume that can reach miles into the atmosphere. This plume can affect weather patterns and air travel. Volcanoes are not all created equal. Each one has its own unique characteristics and behaviors. Their shape, size, and eruptive style are determined by the composition of the magma that feeds them. This composition influences the viscosity and gas content of the magma. Shield volcanoes, with their gently sloping sides, are formed by eruptions of fluid, basaltic lava. These volcanoes can cover large areas with their lava flows. These eruptions, while spectacular, are generally less explosive. They create broad, shield-like profiles. Composite volcanoes, on the other hand, are towering giants. Their steep slopes, built up by layers of lava and ash. These layers tell the story of multiple eruptions over time. The magma that feeds these volcanoes is more viscous, trapping gas and leading to more explosive eruptions. This trapped gas can cause violent explosions. Mount Vesuvius, the volcano that buried the Roman cities of Pompeii and Herculaneum in 79 AD, is a prime example of a composite volcano. Its eruption was catastrophic. And then there are cinder cone volcanoes, smaller cones built up by the accumulation of volcanic cinders and ash. These cones are often found on the flanks of larger volcanoes. These volcanoes are often associated with explosive eruptions, but their eruptions are typically short-lived. They can appear and disappear quickly. Volcanic eruptions, while destructive, are also a vital part of Earth's natural cycle. They play a crucial role in the renewal of the Earth's surface. They release gases trapped within the Earth's interior, gases that helped form our atmosphere billions of years ago. These gases are essential for life as we know it. Volcanic ash, while initially devastating, breaks down over time, enriching the soil and creating some of the most fertile land on Earth. This fertile soil supports diverse ecosystems and agriculture. Chapter 3. Tsunamis, Walls of Water Unleashed. The ocean, vast and powerful, often evokes feelings of tranquility and serenity, a place where one can find peace and solace. But beneath its surface lies a potential for unimaginable destruction, a force capable of unleashing walls of water that can devastate coastlines and reshape entire landscapes, leaving nothing but chaos in its wake. These are tsunamis, a series of waves generated by the displacement of a colossal volume of water, often triggered by natural events. Unlike wind-generated waves that ripple across the ocean's surface, tsunamis originate from deep within the Earth or from catastrophic events on its surface, such as underwater earthquakes or volcanic eruptions. Imagine an earthquake, its epicenter on the ocean floor, the seabed violently thrusting upwards, displacing billions of tons of water in an instant. Or picture a massive landslide tumbling into the ocean, its impact creating a ripple effect that travels across the water's surface, gaining momentum as it moves. These are the seeds of tsunamis, the initial disturbances that set these powerful waves in motion. In the open ocean, a tsunami might pass unnoticed, its waves barely a meter high, spreading across the vast expanse with little indication of the destruction it carries. But as these waves approach shallower water, the ocean floor begins to interact with their energy, altering their behavior dramatically. The waves slow down, their energy compressing, forcing the water upwards, growing in height, transforming into towering walls of water that can reach unimaginable heights. As these monstrous waves approach the coastline, they don't break like ordinary waves, but instead they surge inland with unstoppable force. Instead, they surge inland, a relentless wall of water carrying immense energy, inundating coastal areas, leveling structures, and reshaping the landscape in a matter of moments. The 2004 Indian Ocean tsunami, triggered by a massive undersea earthquake, stands as a grim testament to the destructive power of these waves, a stark reminder of nature's fury. The tsunami, one of the deadliest natural disasters in recorded history, claimed the lives of over 230,000 people across 14 countries, leaving a trail of devastation in its wake, altering countless lives forever. But tsunamis are not merely agents of destruction. They also serve as powerful reminders of the interconnectedness of Earth's systems. How events in one part of the planet can have far-reaching consequences, affecting lives and environments far from the source. The study of tsunamis, their causes and behavior, is crucial for developing early warning systems, giving coastal communities precious time to evacuate and minimize the loss of life, and ensuring that we are better prepared for future events. Natural disasters are powerful reminders of Earth's dynamic nature. We live on a planet that is constantly changing, shaped by forces that operate on a scale far grander than our own. From the tremors of earthquakes to the fiery breath of volcanoes and the devastating power of tsunamis, these events remind us of the raw energy that lies at the heart of our world. But these events are not random acts of chaos. They are governed by scientific principles, by the laws of physics and the intricate workings of our planet. By studying these forces, by understanding their causes and patterns, we can better predict and prepare for their impact, mitigating the risks and building a safer future. What fascinates you most about these forces of nature? Let us know in the comments.